Faster than the fundamental framework of spacetime itself, it possesses the capability to maintain awareness of it. Consequently, it will gradually dismantle this notion, filling me with an increasing unease. At this very moment, our night sky is undergoing rapid transformations, and within the upcoming decades, perhaps even sooner, it could become entirely unrecognizable. Experts, including Neil deGrasse Tyson, have begun sounding alarms, acknowledging the inevitable changes brought about by the shifting of Polaris. The underlying reasons behind this shift are surprisingly unforeseen. Polaris, commonly referred to as the North Star, has been a reliable fixture in the sky for centuries, serving as a vital point of reference for astronomers, navigators, and stargazers. However, this could soon be altered, changing the way we perceive the heavens and how we study the universe. Let's delve into the implications this transformation could have for us. For centuries, Polaris has acted as a guiding light for sailors and astronomers, remaining steadfastly positioned in the sky. Its consistent presence has been crucial for navigation, but this stability may soon be upended. A paper published by the esteemed Royal Astronomical Society in September 2023 raised concerns about the future of this celestial marker. Polaris is entering a turbulent phase, one where it might eventually explode, vanishing from sight forever and drastically altering the sky as we know it. Before considering the possible outcomes of this event, let's take a closer look at the characteristics of the star itself. Polaris stands out due to its proximity to the celestial North Pole. Positioned directly above Earth's northernmost point, it appears almost motionless in the sky. It resides within the Ursa Minor constellation, commonly recognized as the Little Dipper. Polaris shines with moderate brightness, resembling a yellow-white supergiant star much larger and more luminous than our own Sunday. However, Polaris is not a solitary star. It belongs to a complex triple star system. This system consists of Polaris A and Polaris B as a binary pair, with a third star orbiting them. The gravitational forces between these stars influence their orbits and behavior, and any disruptions in these interactions could lead to fluctuations in their brightness or pulsation patterns. Nonetheless, the precise nature of these forces remains largely misunderstood. Polaris is located approximately 323 light-years from Earth, meaning the light we currently observe from it began its journey a long time ago. If Polaris were to explode, we wouldn't witness the effects for over 300 years. It's even possible that Polaris has already exploded, but we simply haven't observed it yet. Throughout history, the North Star has held great cultural, navigational, and symbolic significance. Its constant position has made it an invaluable guide for ancient sailors navigating across seas and lands. Symbolically, Polaris has represented steadfastness and direction, remaining unchanged in the ever-shifting sky. For astronomers, Polaris has been a crucial reference point in studying stellar movements and variable stars. As a Cepheid variable star, its periodic changes in brightness have provided essential insights into the properties of stars and the behavior of variable stars. This characteristic has also been vital in measuring cosmic distances and calibrating scientific instruments, as its pulsations follow a predictable rhythm, making its behavior easier to forecast. Recently, however, Polaris has shown signs of deviating from its usual behavior. These irregularities in its pulsation cycle have piqued the interest of astronomers, prompting further investigation into the cause of these unexpected changes. Rather than adhering to its typical pattern, Polaris has begun to exhibit erratic dimming, leading to concerns that the star may be nearing the end of its life cycle. This behavior aligns with what is observed in stars approaching their final stages. The gradual increase in Polaris's pulsation period, which was once steady, has been traced back to interactions within its star system. There has been a yearly increase of approximately 4.5 seconds in the pulsation period. While this may seem insignificant, it has notable consequences. Some astronomers speculate that the gravitational forces between the stars in the Polaris system could be influencing these changes in its atmospheric conditions, thereby affecting its pulsation patterns. Others are more concerned that Polaris is entering a critical phase that could lead to an explosion. The similarities between the behavior of Polaris and that of Betelgeuse, another prominent star in the Orion constellation, are striking. Both stars have exhibited complex variations in brightness, raising concerns that they may be nearing a dramatic explosion. Stars nearing the end of their life cycles often exhibit such irregularities before their demise. NASA has expressed more concern over Betelgeuse, but formal attention has yet to be fully directed toward Polaris. As a Cepheid variable star nears the end of its life, it undergoes several stages, including the red giant phase and eventually a supernova explosion. Given the irregular pulsations observed in Polaris, scientists predict that it has entered the phase of helium exhaustion, which is typical for giant stars approaching their end. These irregularities align with patterns seen in stars nearing the end of their life cycles. However, solid evidence of an impending supernova is still uncertain, and astronomers are continuing to monitor these anomalies to better understand the fate of Polaris. If Polaris were to undergo a supernova explosion, it would likely be a monumental event in the sky, potentially outshining the moon and remaining visible for days, weeks, or even months. Its brilliance could drastically alter our view of key constellations like the Big Dipper or Ursa Major, in which Polaris plays a crucial role. Fortunately, Earth would likely remain safe regardless of whether Polaris explodes, due to its size and distance from us. While the explosion of Polaris might not be as visually spectacular as Betelgeuse's, it could still be visible to the naked eye for an extended period, outshining nearby stars. This would undoubtedly capture the attention of astronomers and observatories, generating widespread interest both in the academic community and among stargazers. However, the impact on Earth's environment or ecosystems would likely be less significant compared to a supernova, closer to our planet. But what will happen to Polaris itself? What is its fate after a potential supernova explosion? First, it's important to note that while massive stars typically end their lives in a supernova explosion, this is not likely for Polaris. When a large star undergoes a supernova, its core collapses, triggering a violent shock wave that causes the star to disintegrate. However, Polaris is not massive enough to undergo such a violent event. Instead, once it exhausts its nuclear fuel, it will shed its outer layers and transform into a white dwarf. This transition will not lead to a supernova, but rather a quieter conclusion as Polaris evolves into a small, incredibly dense stellar remnant. A white dwarf is the compressed core of a low to medium mass star that has used up its nuclear fuel. This remnant, though roughly the size of Earth, will still have the mass of the Sun. Once this process occurs, we will no longer observe Polaris as we know it. By comparing the effects of a potential Polaris explosion with those of actual supernova events, we can gain valuable insights into the evolution of stars and their ultimate fates. For instance, supernova events like SN 1987A, SN 2011FA, and SN 2014J have provided important data that help us understand what might happen to Polaris in the future. For example, SN 1354 resulted in the creation of the Crab Nebula, a cloud of material that continues to expand and emit energy across various frequencies, providing astronomers with a rich field of study. Moreover, SN 1987A, which was observed in the Large Magellanic Cloud, offered essential insights into nucleosynthesis and the mechanics of supernova remnants, such as nebula formation and the release of high-energy radiation. These discoveries can help us better understand the unique characteristics of Polaris. The formation of nebulae, like the Crab Nebula, occurs when material ejected during a supernova explosion interacts with surrounding interstellar gas and dust, enriching the gas with heavy elements and contributing to the ongoing cycle of star birth and death. The release of high-energy particles and shock waves from supernovae also has significant implications for astrophysical processes and cosmic radiation. To make a definitive comparison, scientists are studying the differences in the production and speed of ejected materials between Polaris's potential explosion and other observed supernova events. By examining light curves, spectra, and remnants from these events, they can make predictions about the potential explosion of Polaris. This research will help determine whether Polaris's explosion could lead to nebula formation or impact stellar distributions in significant ways. Another critical area of study involves the pulsational variability of stars approaching the end of their life cycles. By comparing Polaris with other supernova progenitors, astronomers hope to gain a deeper understanding of the mechanisms behind stellar explosions. The variation in pulsations in stars approaching death may indicate internal instability or an imminent catastrophic event, offering important clues about the processes that lead to supernova explosions. Despite detailed observations and research, space experts are still puzzled by the irregularities in Polaris's behavior. Understanding the causes behind these anomalies is crucial for advancing our knowledge of stellar evolution. The investigation into the factors causing Polaris's erratic pulsations requires collaboration across various scientific disciplines and the development of advanced models and observational techniques. The potential loss of Polaris as a celestial reference point raises fundamental questions for astronomical research. Ground-based telescopes and measurements of celestial distances would need recalibration, which would affect the accuracy of cosmic measurements. The disappearance of Polaris would also disrupt navigation systems and cultural practices that rely on celestial markers, emphasizing the significance of this event. The mysterious behavior of Polaris highlights the need for further studies and focused research. Astronomers must address the complexities surrounding its irregular pulsations and provide meaningful answers to determine the star's future. The study of Polaris is not just a matter of scientific curiosity, but also a matter of significant practical importance. For centuries, its constant position in the sky has been relied upon for navigation, particularly for travelers navigating the vast oceans. Ancient explorers and sailors used the North Star to chart their courses across seas and to orient themselves in otherwise featureless landscapes. In a similar vein, astronomers have used it as a fixed point for celestial measurements, enabling them to track the movement of other stars and determine distances in space with great accuracy. Should Polaris cease to serve this role, or worse, vanish entirely, it would pose a considerable challenge to both modern navigation and the field of astronomy. In terms of technological implications, the disappearance of Polaris would force a major recalibration of various astronomical systems. Telescopes and other instruments that rely on a fixed point of reference would require updates to account for the changes in the sky. This would extend to the myriad of systems and devices that rely on precise measurements of celestial positions, including global navigation systems. Satellites, which use a range of celestial bodies to ensure accuracy, might also experience disruptions, forcing a widespread overhaul of navigational technology. Culturally, the loss of Polaris would also be felt deeply. For thousands of years, this star has been a symbol of constancy, guiding not only seafarers and astronomers but also people from all walks of life who have looked to it for guidance. Many indigenous cultures have created myths and legends based on its steadfast position in the sky. The star's disappearance would, in many ways, symbolize a broader shift in how humans relate to the universe, and could lead to shifts in cultural and spiritual practices centered around the stars. Polaris's eventual transformation into a white dwarf, while not as dramatic as an explosive supernova, still represents a profound end to an era. Once the star sheds its outer layers and begins its slow, inevitable cooling process, it will no longer be visible to the naked eye. This will mark the end of an era for astronomers who have relied on it for centuries. However, the transition to a white dwarf will likely be a gradual one, and while it may not offer the same explosive spectacle of a supernova, it will still be an event of profound significance in stellar evolution. The remaining stellar remnant of Polaris will not be able to sustain the same bright luminosity it once had, and its eventual cooling will make it less and less observable over time. What is particularly fascinating about this process is the insight it provides into the life cycles of stars. As we observe Polaris's changes, we are not just witnessing the end of a single star's life, but also a key moment in the broader cycle of stellar birth and death. In many ways, Polaris's fate mirrors the eventual outcomes for many stars that go through similar life stages. Understanding these processes helps scientists predict the behaviors of other stars in similar situations, and it also helps them refine our understanding of the ultimate fate of our own sun. Interestingly, the research into the pulsations and behavior of Polaris may lead to further discoveries in the field of astrophysics. Understanding the causes behind the star's erratic behavior could lead to breakthroughs in the study of stellar dynamics, which could in turn impact our understanding of how stars evolve over time. The pulsations of Cepheid variable stars like Polaris have long been a key tool for measuring distances in the universe, and by studying the ways these stars behave as they approach their final stages, scientists can refine those measurements and improve our understanding of cosmic scale. While some may view the disappearance of Polaris with trepidation, it is important to recognize that such cosmic events are part of a much larger process. Stellar evolution is ongoing, and the changes we witness in the sky are the result of natural processes that have been occurring for billions of years. The eventual transformation of Polaris into a white dwarf does not mark the end of our exploration of the stars, but rather opens a new chapter in our understanding of the universe. As astronomers continue to monitor and study the anomalies surrounding Polaris, they will undoubtedly uncover more insights into the nature of stars and their evolution. In a sense, Polaris's fading from the sky would not be a singular event but a part of a broader cosmic symphony, playing out over millions of years. Other stars will continue to rise and fall in the night sky, taking Polaris's place as the focal point for navigation and celestial measurement. In the grand scheme of the universe, the loss of a single star is but a fleeting moment in the vastness of time. Yet, the impact on human history, both scientifically and culturally, would be profound. While the disappearance of Polaris may alter our view of the heavens, it would also encourage us to look deeper into the mysteries of the universe, to seek out new stars and new ways of understanding the cosmos. As the scientific community continues to monitor the changes occurring in Polaris, the importance of this research cannot be overstated. It represents a critical moment in our journey of discovery, pushing the boundaries of our understanding of how stars live, evolve, and die. The fate of Polaris is still uncertain, and while the potential for a dramatic supernova remains speculative, the gradual changes it is undergoing offer a unique opportunity for scientists to study the processes that lead to the death of stars. Whether or not Polaris ultimately undergoes a dramatic transformation, the knowledge we gain from studying it will have lasting impacts on the field of astronomy. As astronomers continue to observe the star's behavior and gather data, they will contribute to a deeper understanding of the forces shaping our universe. In turn, this knowledge will help refine our models of stellar evolution and improve our ability to predict the fates of other stars in our galaxy and beyond. Ultimately, the study of Polaris serves as a reminder that the universe is constantly evolving, and our place within it is but a brief moment in time. While the disappearance of Polaris might be an unsettling prospect for some, it is also an opportunity for humanity to embrace the ongoing quest for knowledge and discovery. Through continued study and observation, we will unlock new insights that will shape our understanding of the cosmos for generations to come.